Hey, welcome back. This one is lesson 7.4, trig equations with calculator. Basically, the equations aren't that long or anything. They're simple equations, and we shall have to use a calculator because we're not going to find these values on our unit circle. And this is lesson 7.4, and again, if the 7.4 does not match up to what we did in class, the topic is the same, trig equations with calculator. So what you see in front of me is a big giant table. I kind of created the table to summarize how to find theta using calculator, although we're going to try and see if we can go by our understanding as well. You can pause the video at this time and go ahead and copy this table because I'm going to be referring back and forth to the table. Hopefully you're done copying it now. So let's go ahead and see how to read this. All right, the first column is the positive value column, and then depending on what type of question you have, if you have a cosine question with a positive value, then we're going to refer to these two formulas. If you have a tangent question but with a negative value, then we're going to refer to these white formulas. Like, we all know how to use tables. Let me show you examples so it starts to make sense. Let's say I have this very first example, sine with a positive number value, and then sine question with a negative value. What am I trying to find here? The missing part is, or the unknown is the theta. The way you want to read this is that sine of what angle will equal 0.83. Now I can find the theta by plugging in sine inverse of 0.83 in the calculator. Also notice this is a sine question with the positive value, sine positive. All we have to do is use these two formulas. So theta 1 is basically sine inverse of the number. Now once you plug that in, we shall get its value. Make sure your calculator is in radians. Let me actually plug out calculator. Alright, the first thing you want to make sure, we want all the answers in radians that your calculator is set to. Radian mode, which you can find under the radian button. This one turns out to be 0.97910, yada yada yada. It's a long one. And remember, this is the angle written in radians. So for now, I'm going to write radians every time. And I found the first angle where sine will have that value. And the second one, you can simply find it by subtracting your first answer from pi. And all you have to do is plug this into the calculator. You can get the initial answer also from the calculator, which should be sitting on your screen. Just bring it down, and this ends up being 2.1624, yada yada yada. So basically I found two angles. If I were to round to the thousandths, one is 0.979 radians and the other one is 2.162 radians. And I found both the angles where sine value will equal 0.83. Now the idea behind these formulas that I plugged in was that when sine is positive, sine's positive in first quadrant and second quadrant. Sine is the y-coordinate and y-coordinate is positive above x-axis. So when we punch this in, theta 1 into the calculator gives us this angle. To find the other angle, which is this one, all we do is, if we look at the straight line, that's angle pi. If you subtract the first answer from pi, which is the straight line, we automatically get this other angle. And that's why we do this part here. Moving on to a sine question that has negative value, we're going to use this box, sine with negative values. The way you want to read this is first we'll find an angle x by plugging in sine inverse of the positive number. So for now, you're going to just ignore that negative even exists. We're going to find our x value by plugging in sine inverse of 0.34. As I said, just ignore the negative for now. Get the x angle first. This one turns out to be 0.347-ish. I rounded it to the thousandths. Once we have the x is going to help us find both the angles. The theta 1 is going to be pi plus x plus this number, 0.347. I'm going to go ahead and punch into the calculator, 3.489. I rounded it. Theta 2 can simply be found by subtracting x value from 2 pi. And that turns out to be 5.936 radians. So both the answers are. Check to see on Math Excel what they want their rounding to be. I'm rounding to the thousands. Math Excel may ask for hundreds. So just be careful with that. So I showed you sine and negative sine. Look at example 3. This one says 11 cosine theta minus 5 equals 4. And the idea is still to find theta. So this is just like an equation. First thing you would do is add 5 to both sides. Equals 9. And clearly we will divide by 11 on both sides. And I end up with cosine theta equals 9/11, which is going to be slightly less than 1. You can convert that to decimal, but I shall leave it right there and let the calculator handle that. So we're basically trying to find an angle theta where cosine value equals 9/11. Obviously, this is not on unit circle, so we shall follow the cosine with positive value formulas. This one. Or these two. First one can be simply obtained by plugging in cosine inverse. And you can tell. And you can tell what happened. All right. Cosine theta is 9/11. So theta 1 would be cosine inverse of 9/11. And you can just simply plug that in there. Let the calculator take care of the decimals. And we get 0.6125-ish. Theta 2 is simply 2 pi minus the first answer, minus theta 1. That turns out to be 5.6706-ish. And comes in rounding time. I found both the angles. It's 1, 3-ish because this was a 5. And comma 5.671 radians. Both the angles. Again, well, how did we make this up here? Because cosine would be positive in the first or fourth quadrant. Because it's an x value. X is positive to the right of y-axis. So when I punch in the first one, which is this one, I get this angle, which is 0.612, And how to find the second angle, which goes all the way around here. Remember, this is not an inverse question, so we are not going to write it as negatives. This bigger one can simply be found by subtracting the first angle from 2 pi. Because this is the only part we have to eliminate, which is the same as the first one. So that's the concept of that. Moving on to the one on the right, example 4, secant theta equals a negative value. Well, first of all, we all know secant is not on there, on the calculator. So let's write its reciprocal, which is cosine theta. Well, if I reciprocal one side, I got to reciprocal the other one as well. And I reciprocaled it. Now this has converted into a cosine question with negative value. So what shall I follow here? Cosine with negative value, which is the red one. So look carefully. We'll first find x, cosine inverse of the positive value. We're going to pretend the negative doesn't exist. So we're going to plug in cosine inverse of 1 divided by 2.5. X turns out to be 1.1592 radians. Now that x value will help us find both our angles. The first one can be found by going pi plus x and then pi minus x. And we should already have that value up here. Plus x gives me 4.3008. Yada, yada, yada. Minus the x value gives me 1.9823, all that. So we found both of them, but again, write the smaller one first. 982 rounded to thousands, and 4.301 rounded to thousands. Those are the two x values, tangent theta values. How does that make sense? Cosine is negative, if I were to draw it here, cosine is negative in these two quadrants. So when you plug in the first, when we end up finding the positive value first, which means right here. And now I'm going to use this pink arrow, which gave me the first radian, 159, to find the other two orange ones. Because we are actually looking for this angle and this angle. Because cosine can only be positive, as I said, in the second or third quadrant. So the pink one, pi plus the pink value, which is how we got the first angle, it simply gives me the bigger angle, the bigger yellow one. You can clearly see this makes a straight line. Together they make a straight line. So if I take the pink one and then add a whole half a circle to it, I get the bigger angle, the bigger yellow one. And the smaller yellow one is basically using this as a straight line and subtracting the pink one from it, which automatically gives me the smaller yellow angle in radians. That's an interesting video. It's going to be an interesting one. I think Siri heard me and she started something on my phone. Okay. Then comes another one. I think this is number 5. And I see 6 cotangent theta equals -7. Of course, we're going to get rid of this 6. Cotangent theta equals -7, 6. This is a cotangent question, and we shall convert it to tangent, which is the reciprocal, which also means I'm going to reciprocal the value as well. Now this has changed into a tangent question with negative value, for which we shall refer to these right formulas. And again, if you've noticed a pattern, if we have a negative value, we first find the corresponding trig function for the positive value. So let's plug in. We can find x by going tangent inverse of 6/7 to get the x value. 0.7086, and that shall help me find both the angles. First one can be found by going 2 pi minus x, and the second one can be found by going pi minus x. Okay, time to plug those in the calculator. Please be using the pi that's inbuilt in the calculator. 5.57 4 5 2.4329 and so on and so forth. And both my answers, always write the smaller one first. 3 and 5.574, and that shall be 575 radians. Okie dokes, and the tangent concept works the same way as I showed you before. When I tried that look in this equation, clearly we shall get rid of the 18. Negative 46. No, in the 3, yeah, 46. Divide both sides by 16. Cosecant theta equals negative 46 over 16. And now it's time to convert this into a sine problem. Reciprocal it, which means reciprocal that as well. This does simplify to negative 8 over 23. And I shall just use negative 8 over 23 for sine values. This one matches, this is a sine question with negative values, so I should follow those rules, which means I shall first find x, which is sine inverse of the positive value. Let's find that. .35525. And that shall help me find the first angle, which shall be, so we are using this one again, pi plus x and 2 pi minus x. And try and do these yourself on the calculator, or even Desmos. Desmos should work as well. In fact, I know it will work. You can also swap your radians and degrees in Desmos. So make sure you're in the radian mode. Other than just watching me, if you are punching in these numbers while pausing me in between, that will just help you understand it better. And assuming that we had copied that chart. So both my angles are 3.497 and 5.928. Alrighty. And the last one I have here is one step more because we have fractions here. When you look at this, you can actually temporarily replace that with an x and convert it to an Algebra 1 problem. Right? And then from here, cross multiplying was something we used to do. 15 times 7, 105x, and 9 times 4 is 36, and x is 36 over 105. I'm not going to worry too much about simplifying it, but it's time to bring back the cosecant theta, 36 over 105, and you can clearly see this needs to be changed into a sine problem, reciprocating everything. What happened here is, let me make sure I did it right. Yeah, I did do it right. So 105 divided by 36 is going to be a number much greater than 1. So sine theta 2.916, this is the value. But again, if you remember sine range, the range for sine is between -1 and 1. The sine graph does not, the parent sine graph doesn't go over 1 or under -1. So having this value is undefined. And if you quite don't see that yet, then just pretend you were just doing the problem regular. You would plug in theta 1 would be sine inverse of 2.916. And the minute you do that, your calculator will give you an error. Why? Because they are programmed to know that the range of sine is between -1 and 1. So it should give you error, which means we don't have any answers. There is no angle where sine value will equal 2.916. Okay? Alrighty. That is it for this lesson. Bye.